Matter consists mainly of atoms which are composed of electrons, protons and neutrons. The electron has the electric charge negative E, where E is the elementary charge of size 1.602 times 10 to the negative 19 coulomb. And coulomb here is the unit for electric charge. So that makes the electron negatively charged. The proton has the electric charge plus the elementary charge, which makes it positively charged. So we note that the strength of the charge for the electrons and the protons is identical. They only differ in sign. So the electrons are negatively charged and the protons are positively charged, but the amount of charge is identical. The neutrons, the third elementary particle that we have, are electrically neutral. That is, they do not have any electrical charge. So the charge for the neutrons is 0. Atoms are electrically neutral. So by necessity we need an equal number of protons and electrons to form an atom, because then the positive charge of the protons will be exactly cancelled by the negative charge of the electrons if there are equal number of protons and electrons. If we would have an atom and we remove an electron, then we'll get a positively charged ion. Because then as we remove one electron, there will not be equal number of protons and electrons, and as we sum them up, we'll get a net charge that is non-zero. In the same way, if we have an atom and we add an electron, again we get an ion, then that ion will be negatively charged. So here is an example with the helium atom. And the helium atom has a nucleus with 2 protons, shown by the circles here with a plus, and it has 2 neutrons. They are shown by the circles with the big N. So that makes the total charge for the nucleus equal to plus 2 times the elementary charge. And here I denote the total charge by small q. I will also use big Q at times, but this is the way to typically denote the total charge of some sort of entity. In this case, it's the nucleus, the total charge of the nucleus. I denote by Q here. It's plus 2 elementary charges. And then around the nucleus we have electrons orbiting in an electron shell with 2 electrons, and therefore the total charge of this electron shell will be negative 2 elementary charges. So here we see that the total charge of the nucleus is just as big as the total charge of the electron shell, but the two differ in terms of the sign here. So as we add them up to get the total charge of the entire atom, then we get a net charge for the helium atom that is 0. And that comes from the fact that we have just as many electrons as protons. Should we remove one electron from the shell, then we will have 2 protons, only 1 electron, and that will make this an ion, a positively charged ion. Would we add an extra electron to a helium atom, we would have 3 electrons but only 2 protons, and that would give us a negatively charged ion. It's possible to add and remove more than 2 electrons as well. The diameter of this helium atom is about some 280 picometers, and if we take the population on Earth, some 7 billion people, a little bit more than that, and we take as many helium atoms as we have human beings on Earth, and we sort of place them on a line like this, then that line will be about some 2 meters long. So that is to just demonstrate how small these atoms are. Now, all matter that we have around us on Earth and in the universe, let it be solid matter such as, say, iron or glass or plastic, these solid objects are composed by atoms typically. And if it's say a liquid material like water or oil or another liquid, it also consists of atoms, possibly bundled together into molecules then, which is quite normal. And the same thing for gases. Say helium gas would ideally consist only of helium atoms, but then in gas form, and obviously there are plenty of different gases. Air is a gas that is a mixture of different gases that contains only one type of, say, atoms or molecules. So this is the way our universe is sort of built, and the purpose of this has been to demonstrate how the electrically charged particles at the lowest level, electrons and protons, enter into the universe, and it's the electric interactions in between these particles that we're interested in. And given these particles, we could also get charged ions, electrically charged ions, or maybe electrically charged molecules. If we put together several atoms and then we remove one or several electrons, maybe we add one or several electrons to this composition of atoms, then that makes a molecule that can be electrically charged, have a total charge that is non-zero. But we could also have big objects like a piece of metal, and that piece of metal, we remove a number of electrons from that piece of metal, and then that piece of metal will have an imbalance in between the number of protons and electrons, and that will make that entire block or piece of metal electrically charged. So this is how the electric charge enters into our description of the world that we have around us and the matter that we have around us.